Hello, good day. I'm Dr. Ranith. I'm a scientist at Nansen Environmental Research Center, India. So today I'll be talking a bit about one of my research work using GHRSST data in understanding coral reef bleaching and thermal stress along Indian reef system. So coral reefs basically constitute of small cnidarian animals called as polyp, so which has zooxanthellae in its epidermal layer. So when the environmental condition is not optimum, especially when temperature increases beyond a threshold level, then polyp expulses zooxanthellae, results in the whitening of coral colonies. And this process is called as coral bleaching. So coral bleaching has a detrimental impact in the global coral reef system because coral reef ecosystem depends on recovery after a perturbation. What if the frequency of perturbations is much more during the recovery period? So in those situations, corals fails to recover, resulting in a phenomenon called as phase shift. Over the past 2 decades, coral reefs in Indian ecosystem has experienced higher number of coral bleaching events, with Gulf of Mannar has the maximum, which is about 10 coral bleaching events in the last 2 decades. So as I discussed before, though recovery is possible after a bleaching event, it may take decades or years. And the increasing frequency and severity of perturbations like coral bleaching, as seen in Gulf of Mannar during last 2 decades, it will hinder the process of recovery that results in the overall reduction of coral reef biodiversity. So changes in coral diversity with more thermally susceptible branching corals increases the regional coral reef sensitivity to rising temperatures. So recent studies have showed the impact of marine heat waves in causing unprecedented stress and inducing rapid regional coral bleaching events with sensitive thermal history. So this aspect of thermal stress to the major coral reefs of India like Gulf of Mannar and Lakshadweep was assessed in this study. So based on the bleaching responses, we also tried to classify the thermal ranges into safe and risk zones so that we could able to define a safe operating temperature space for corals using the 30 years of GHRSST data, that is from 1992 to 2022. So now we will see one of the most commonly used coral bleaching metric, which is degree heating week index. Degree heating week index is a commonly used metric to monitor and predict coral bleaching events. But recent studies showed that the degree heating week metric mostly fails in identifying small scale regional bleaching events, as the degree heating week calculation uses a cumulative temperature of over a period of 12 weeks. So the question is like this. So what happens if a small scale bleaching happened from a temperature anomaly over a period of 5 days or 7 days? Then that kind of information cannot be considered into the degree heating week calculation. So degree heating week fails in identifying those small scale regional bleaching events. Whereas in the case of marine heat wave, which is defined as a period in which the water temperature above the 90th percentile of the area's historical condition, and if it persists for a period of 5 or more days, then it can cause intense stress in that region. So this is based on the definition of Hobday et al. 2016. So in the case of marine heat wave, the cumulative temperature is considered for a period of 5 days or more. So if there is a bleaching which happened from a cumulative temperature for a period of 5 days or 7 days, that can be concluded or that can be included in the marine heat wave calculations, and hence marine heat wave could be able to signal those small scale regional bleaching events. Considering the increase in frequency of bleaching events in the last decade, as I told you, Gulf of Mannar has experienced almost 10 bleaching events in the last decade. We try to understand the trend of thermal stress in Indian corals using two regions as a case study, Gulf of Mannar and Lakshadweep. Coral reefs being a very dynamic ecosystem and the coral bleaching being a very dynamic process, the data that we will be using should be of good resolution in terms of space and time. GHRSST, optimally interpolated sea surface temperature data, provides daily data at a good spatial resolution, and hence it can be well used in studying dynamic processes like coral bleaching. Here we try to derive the major SST metrics like sea surface temperature mean, minimum sea surface temperature, maximum sea surface temperature anomaly, maximum monthly mean climatology, marine heat wave intensity, marine heat wave duration and frequency for both Lakshadweep and Gulf of Mannar. So based on the analysis, it was clear that highest cumulative degree heating week was observed in Gulf of Mannar during the last 3 decades. So the value was around 940.8 degrees Celsius weeks. So which was much higher than what we observed for Lakshadweep. Lakshadweep has encountered around 564.96 degree Celsius weeks during the last 3 decades. So this basically shows that Gulf of Mannar had a more warmer condition than Lakshadweep in the last 3 decades. Maximum intensity of marine heat wave was also recorded highest in Gulf of Mannar, which ranged from 0.92 degrees Celsius to 2.12 degrees Celsius. Whereas in the case of Lakshadweep, the marine heat wave intensity was ranged from 0.72 degrees Celsius to 1.27 degrees Celsius. We also tried to identify the spatial trend of marine heat wave intensity over the last 3 decades in Gulf of Mannar and Lakshadweep using a generalized linear model. So that also showed a statistically significant increase in trend of marine heat wave intensity in both Gulf of Mannar and Lakshadweep. So which shows that Gulf of Mannar and Lakshadweep, especially Indian reefs, are highly vulnerable to bleaching and they are exposed to increasing thermal stress over the period of time. With the increased degree heating week, increased sea surface temperature anomaly and increased marine heat wave intensity in Gulf of Mannar system is more vulnerable to bleaching, and which explains the increased number of bleaching events which happened in Gulf of Mannar over the last 2 decades. Considering the complexity in degree heating week and marine heat wave metrics in explaining regional small-scale bleaching events, here we tried to develop a simple SST-based metric to define the safe operating thermal space for coral reefs. So for that, we used a 2-step cluster classification methodology to compare the SST minimum data and SST maximum data daily, which was obtained from the GHR SST, with that of the coral bleaching intensity. So coral bleaching data was obtained from secondary biodiversity databases as well as from our own field observations. So based on the cluster analysis, 3 zones were delineated. There was a high risk zone where corals have high chance to undergo bleaching in that particular range of temperature. There is an uncertain zone where paling occurs. There is no definite bleaching happens in that particular range of temperature. There is a safe zone where corals have no chance of bleaching. So in that particular range of temperature, the vulnerability for corals to bleach is nil. The coral bleaching thermal thresholds defined for Indian reefs by Vivekananda et al. 2008 fall in the same temperature ranges for high risk and uncertain zones in our safe operating space analysis. In conclusion, Gulf of Mannar was found to be highly vulnerable to coral bleaching compared to Lakshadweep. So here we have to identify a fact that though these 2 reef systems are within the Indian water domain, they act differently towards the vulnerability to bleaching. The uncertain zones which we have identified during our safe operating thermal space analysis are risky, as these zones could develop into high risk areas in the near future with an increase in the temperature response and also from the increased prevalence of thermal sensitive corals like Acropora in the region. So that has to be studied, monitored and assessed properly. This study explains the significant use of high resolution sea surface temperature data, and GHRSST provides potential opportunity to monitor, predict and model coastal processes like coral bleaching with good certainty. Thank you.